Now coming to the OCP agent implementation, if you see the OCP interface, it's a single interface with all address, data and the responses going through the same interface. Thus, if you want, you can define a config OCP config object with a virtual interface handle and add all other information needed to populate the OCP client, or you can directly pass the OCP virtual interface handle through the UVM config DB from the top level test bench module. The OCP slave sequencer is a typed of the UVM sequencer with parameterization of OCP transaction, and the OCP slave driver is again parameterized with the OCP transaction, and it contains the handle to the virtual interface, the OCP virtual interface. And also there are two inbuilt OCP transactions queues for the input request and response transactions. This is a way in which the driver is designed. The driver will watch the input interface for any request that is coming in. It can be a read request or write request, and it will push that input interface request to a queue, and also it will manage to drive the response back through the response interface. And whenever we got a complete request interface, we can fill the response information and push it to a response queue, and a separate task can drive the response in the OCP interface. So in the build phase function, you should get the handle to the virtual interface using the UVM config DB. The connect phase is an empty function, and in the run phase task after the reset, you are forking three tasks. One is to manage the input sequencer transactions, and next one will watch the inward request, that is a read request or write request at the interface, and the third task will manage the responses for the input request. Thus you can see that the manage sequencer transaction will wait for an input transaction to come, and also once it got an input transaction from the sequence, it will wait and for an event to be triggered. So this event, that is a new input request received event, is triggered from another task. So you can see that this event is also a member of the driver task. So this is, we are adding here the event with the name new input request received. And when this event is triggered, we are driving the sequence item port dot item done, which makes the sequence, the OCP slave sequence, to go to processing the next transaction. Thus, the OCP slave sequence will be in a waiting state till we are till this event is triggered in the driver, or which is eventually till we are getting an input violate transaction in the interface. So this was a second task that was forked from the run phase. You can see that it is waiting for a write transaction or a read transaction, and if it is a write transaction, this task will wait till all the write data is available, that is till the last signal is asserted. That means the whole data is available for this write, and it is putting into a transaction and pushing into the interface input request queue. And at this point, when you are getting the whole write information or the whole write transaction, this event called as new input request is triggered here, and this will unblock the manage sequencer transaction task from here, and it will fill the it will unblock the sequence eventually by calling the seek item port done task. And in the same way, you can see if it is a read transaction, after monitoring the transaction, it is pushed back to the response queue, and it is again triggering the same event. And in the drive interface response queue is the third task that was forked from the run phase, and this should actually send back the responses to the driver, which is omitted here. So for the read transaction, either you can locally generate the response here by using an internal local transaction and a randomization, or you can use the same read transaction that is driven from the sequence. But if that is the case, you need a synchronization between the number of read transactions and the number of transactions and the order in which the read and write transactions are driven from the sequence. So this is OCP monitor class, which is extending from the UVM monitor. There is a virtual interface handling this, and also there are two analysis ports, that is the OCP write port and the OCP read port. So through these ports, we will be sending the write transaction and the read transaction that is received in the interface. And in the build phase, you are creating the read and write ports, and also you are getting the handle to this virtual interface through the UVM config DB. Now in the run phase task, you are forking two tasks, that is the monitor input request and the monitor output response. And in the monitor input request, whenever we have a complete write transaction available, that is when a write opcode with the last is there, we are creating that write transaction and filling all those values and finally writing it back to the write airport, OCP write airport. And in the same way, you should put the code for the read transaction also. That is, if this is a read, you should wait, you should synchronize with the input read request and output read response, and the monitor output response task will eventually fill the response that is sent from this driver or the OCP slave to the interface, and it will fill all this information regarding the read transaction, including the response data. And when the read response is completed, it can write the read transaction to the read airport. Now coming in the final OCP agent class, the class OCP slave agent is extending from the UVM agent, and it has got the OCP sequencer, driver and monitor handles in there. And also if you need, you can add a configuration object. Also we'll be declaring two analysis for the OCP write airport and OCP read airport. And in the build phase function, the sequencer, driver and monitors are created using the UVM factory, and also you'll create the read and write airport instances. In the connect phase function, you will connect the driver sequence item port to the sequencer sequence item export. Also you will make the connection of the airports, the read and write airports in the OCP agent to the airports present in the OCP monitor. Thus you have implemented the OCP slave agent also. Next is the implementation of the scoreboard class.